Welcome. We have Robert Aish with us, who is the Director of Software Development with Platform. Welcome.
Hi, thanks.
So, what is design computation?
Well, we've been using computers in design for about 30 years now, and many of the applications that have been developed are really analogues of what designers did before they had computers. They sketch and they draft and they model, but they haven't really used computers in a computational sense with algorithms. So what design computation is about is enabling people to write algorithms to generate buildings. So rather than just manually draw them, in fact, when you look at somebody using a CAD system, you often see them beavering away very feverishly using the system, is rather to step back from that interaction and say, are there rules that underlie a particular building? And can we encode those rules in an algorithm? And can we then build the model of the building, for example, by executing that algorithm? And the advantage of that is that if you want to change the building, you don't have to go around manually interacting with the model, I want to change the size of the windows. You change one parameter and the model is rebuilt using your design rules. Okay. So where there is a very complex rule-based building, it's far better to recognize that, write the rules, execute those, and then you can iterate through many different building possibilities and choose the one which is most appropriate.
Well, that explains what design computation is. So how does it relate to the users?
Well, many users are already using these techniques. We've had scripting languages in AutoCAD. We had AutoLisp, for example, Visual Basic, now with the .NET languages. But these are very much for people who are programmers. So we're looking at the space in between people who are application programmers and people who are regular designers who have excellent modeling and drafting skills. How can we bridge that gap so that designers without traditional programming knowledge can begin to express their design in an algorithmic way, mainly by capturing their existing interaction and recording it as a script, and then they can look at that and play it back, and then they can embellish it with extra logic. So it's really designing a learning curve so people with good design and modeling skills can acquire some algorithmic skills and then can progress on to become programmers if they want to.
Right. Now, well, I guess you did. Did you give me some? Can you give me some more examples?
Well, a number of buildings now are, if you like, non-standard. With digital fabrication, it's possible to make components for buildings that don't have to be standardized. So a lot of the architecture we see at the moment is the result of standardization. But if you can make, for example, if you had a curved roof of a sports stadium, you could make individual panels for that roof. Each one could be different. It would not be more expensive to make unique panels than standard panels. And then that gives the possibility to make a much more adventurous sculptural architecture. Okay? The question is what tools would you use to know what would be the dimensions of all these panels, how to drape those panels over the underlying, on the underlying surface. And so that's where design computation comes in, because you wouldn't want to draw each one of those panels manually. You want to set up the rules to populate that surface with those panels. So it's coming from a number of design computation. The idea of design computation is coming from a number of different directions. It's coming from the interest of designers in computation. It's also coming from advances in digital fabrication, and it's coming from advances in software that Autodesk is producing.
So is it cool?
Absolutely, because you can do things that you couldn't do before, and that's the most important thing. And we will see on the main stage on Tuesday one example of the Centre Pompidou building in Metz, which has been designed with this technique. So that's,
and when is that going to be again?
That's going to be in Carl's keynote at the main stage on Tuesday morning.
All right. Well,
Really
thank
good.
you very much.
Thank
you
you
very much for joining us.
Thank you.
And thank you for joining us.